Welcome to an example in which we've got a population numbers 18,000 organisms initially and grows by 2.5% each year. This is called exponential growth. So you can see the word exponential right there. So when something grows by the same percent each period of time, be every year, every week, every whatever period of time, that's called exponential growth. And also if it shrinks, we call that exponential decay. So this is exponential when you grow by the same percentage every year. So how do we do this one? Well, we have right here's the notes, the class notes, and I'm explaining here exponential growth or decay, definite time period versus continuous. So there's two ways exponential growth may be stated. Two different ways. They can say it two different ways in our homework and on the next exam. Got to be aware of two different ways. One of them, they can give a definite time period, like here, like a substance decays by 5% per year. You would use this formula. P is the amount at the start. R is the decimal version of the growth rate, positive or negative. Versus no definite time period. Like they say, a substance decays exponentially or continuously. Then you would use PERT. So it's a different formula. So whenever they mention exponential growth or growing by a percentage, so if they say 5% per year or 3% per week or whatever, then you're going to use this formula, A equals P 1 plus R to the T. Whereas if they just say exponentially or continuously, you're going to use A equals PE to the RT. Two different formulas depending on what they say. So in our case, it's definitely, 2.5% each year. So I'm going to use the formula A equals P 1 plus R to the T. Isn't that what it was? Let me go back here. Yeah, A equals P 1 plus R to the T. Now, I know it can be confusing as you wait, Mr. Aaron, they have a P out here and you put A. Yeah, it doesn't matter. Everybody uses different letters. They're just all placeholders. It's the format. It's the parentheses, the thing up in the power zone, the 1 plus a number and something in the front. That's what matters. So I'll just use the way the notes say. Okay. And then how do we know what's going to go on? Well, as it says right here, see how it's going to be the 5% became 0.05, and it was minus in this case because it was decay in this example, right? It said decays. But if you have growth, like our example, growth is plus. So in other words, I'm going to go 1 plus, and I'm going to go 0.025. Do you see that? Because I took the 2.5% and I made it a decimal, right? 0.025. You move it back two places. Let me show that really clearly. So if you have 2.5%, then you're going to go back two places. So I'll go back 1, 2. So it'll become 0.025. It goes back two places when you get rid of the percent symbol. When you change from a decimal to a percent, it moves back two places. So the decimal went bonk, bonk, 0.025. And then I grab the 0.025 and I put it right there. So that's the rate. That's the growth rate. It's like that. Okay. And so then we can write this formula, simplifying it one more step. A equals P, and this will be 1.025 to the T, like that. And one last thing, the initial, yeah, I guess I don't put it in the notes right here. The 18,000 initially, that's the P right there. So I'll make this right here. 18,000. So there is our formula. And so that's what you're going to put in the box right here. So it's 18,000 times 1.025 to the T. That's the format. See how they said they wanted the format right here? Here, let me try that again. They wanted the format to be A. I know they call it P. We're calling it A, whatever, who cares? Don't confuse that with the P over here. It's just Who cares? It's just different letters. But the format's the same. What do I mean the format's the same? Well, look at that format. That's A times B to the T. This is the A, this is the B, right? The format is, they're saying we want it in the form where you have one thing times another thing. There's no symbol in the middle, means times. And the second thing is to the T power. Well, we've got that now. We got the first thing, the A is the 18,000. The second thing is the 1.025. That's the B to the T power. We did it. So again, how do we do it? When they tell you that something is growing or shrinking by a fixed percentage each period of time, that's exponential, and you just write A equals P 1 plus R to the T. You take that percentage to 0.5, change it to a decimal, move it back 2 places, 0.025 when you change the decimal, put it in right there for R, add those together, 1 plus 0.025 is 1.025, and then the initial amount, that's what goes in the front, whether you call it P or whatever you call it, it's the number that goes in the front. And there we go, there's the exponential equation.